Well, welcome everyone. We do not normally do a Research Connects webinar in the summer, but our in-house research team recently attended the Alzheimer's Association International Conference, and we wanted to share some of those highlights and headlines from the conference with you. So I'm Dr. Heather Cook. I am the Manager of Research and Knowledge Mobilization here at the Society. And I'm joined today by my colleagues, Dr. Sarah Wu, who is our Strategic Lead Research. Sarah's at the top of the screen, and also by Cari Randa-Beaulieu, who is our Provincial Coordinator, Knowledge Mobilization. And then also with us today is our co-op student, Maya. This is actually Maya's last week with us before she returns to school for the fall semester, but she's going to be keeping a close eye on the chat today for us. So if you have any questions that come up, pop them into the chat and she'll keep track of us and keep track of those for us when we circle back to them after we've worked our way through some of the slides today. So next slide, please, Sarah. So as we begin today's session, I want to acknowledge that I'm speaking to you today from the unceded and ancestral territory of the Silks Okanagan Nation. And knowledge sharing has always been a vital part of the culture and the traditions on these lands that's been carried through generations in ways that continue to guide and inspire. And so as we reflect on and we share the learnings from the Alzheimer's Association International Conference, I'm really grateful for the opportunity to do so in a way that honors that long history of learning, of teaching, and connection. And I encourage those of you who are joining us for today's webinar to pop into the chat the traditional territories from which you're joining us this afternoon. And I want to also say the beautiful photograph that you see in the background of the slide on your screen was taken on the traditional land of the Hoopachaset and the Seychot First Nations. And I'm now going to turn things over to Cari, and I will be back following the presentation to facilitate today's question and answer session.
Thanks so much for that lovely introduction, Heather. So, the Alzheimer's Association International Conference, or AAIC, is the largest international meeting dedicated to advancing dementia science and clinical practice. Each year, this conference brings together researchers, clinicians, organization representatives, people with lived experience, and industry professionals to share breaking research discoveries, theories, and best practices that lead to improvements in diagnosis, risk reduction, and treatments for Alzheimer's disease and other dementias. This year, over 11,000 people attended in person and online. So 8,000 people came together at the Metro Toronto Convention Center. It was a packed week with a focus on biomedical and foundational science. While it's a global conference, AAIC is hosted by the Alzheimer's Association, which is America's equivalent of the Alzheimer Society of Canada. And the annual conferences often land in major American cities. So last year was in Philadelphia, and future years will be in cities like Chicago or San Francisco. Next slide, please, Sarah. So, as we like to say at the Society, research moves us forward. With Canadian researchers and organizations at the forefront of this year's conference, it was a privilege to represent and amplify some of the wonderful work in BC and connect with inspiring researchers from across the country. So I'm really excited to jump into three of the biggest headlines from this year's Alzheimer's Association International Conference. So I'm going to be starting us off with the gut-brain connection, talking about sleep as potentially the next modifiable risk factor. And then I will hand things over to Sarah, who's going to share some fascinating research on sex differences in Alzheimer's disease, as well as sharing a little bit about what our team presented at the conference. Next slide, Sarah. So you've probably heard about the brain health benefits of the Mediterranean diet, but nutrition is only part of the story. Another way to treat neurodegenerative conditions may be through our digestive system. So, the enteric nervous system is a vast neural network of over 100 million neurons within the gastrointestinal tract. It's been nicknamed the second brain due to its complexity and ability to operate somewhat independently from the brain. Beyond the sheer volume of neurons, this massive neural tissue in our gut produces over 30 different neurotransmitters. Those are the chemical messengers that carry signals from one brain cell to another. You can kind of think of it as text messages sent between brain cells. Despite its role in neurotransmitter production, it's often overlooked in brain health research, although this is starting to change. Next, please. So, the gut brain connection is a bidirectional one. This means that signals pass both ways between the digestive system and central nervous system. Health or disease in one can affect the other. And key parts making up this connection are the network of nerve cells lining the digestive tract. So, that's the enteric nervous system from the last slide. The vagus nerve, the body's longest cranial nerve running from the brainstem down to the abdomen and connecting to various organs along the way, like the heart, lungs, and stomach. And the gut microbiome, that's the ecosystem of organisms, so bacteria, viruses, fungi, and other microbes that live in the intestines. And pathways connecting the gut to the brain include the blood brain barrier and the vagal sensory neurons, which are nerve cells along that vagus nerve running from brainstem to intestines. The blood brain barrier tightly controls what enters the brain. Very few substances make it across the blood brain barrier. It allows good stuff like nutrients and oxygen to get from your blood into the brain while aiming to keep out germs and toxins. And it's not a one way street. Products from the gut microbiome also travel through these pathways and influence brain function. For people who live with Alzheimer's disease, the buildup of amyloid beta and tau disrupts how brain cells work and over time damages these cells. Researchers have found that a well established Alzheimer's disease genetic risk factor, so that's the ApoE4 gene, increased the efficiency amyloid beta and tau are transported relative to people who don't carry that genetic risk. But researchers have also found that tau proteins gather in parts of the gut months before they were observed in the brains of mice. And there's also evidence that tau can be found in the gut years earlier than in the brain in humans. So the potential implications of these findings are huge and challenge existing views on neurodegenerative conditions. Now, researchers are investigating methods to block the overproduction of harmful molecules like amyloid beta and tau, and homing in on how best to use neurons along that gut brain connection as transporters of treatment molecules to bypass the blood brain barrier. This is important because current disease modifying therapies require infusions through a vein in the arm, carried to the brain by the bloodstream. But the large protein molecules don't naturally cross the blood brain barrier very efficiently. By using molecules in the gut microbiome that already travel along the superhighway of the gut brain connection, therapeutics could be delivered to the brain with oral medications. Oral medications are more cost effective and user friendly, and this alternative delivery system may allow for a higher dosage and have less side effects than current disease modifying therapies, especially around swelling and bleeding in the brain. Next slide, please, Sarah. So, some key takeaways from this first piece, if you take anything away, I hope it's these. The gut-brain connection is a bidirectional communication pathway between the gut and the brain that influences brain health, mood, and cognition. The gut microbiome, that's the community of microbes in the digestive system, plays a crucial role by sending signals to the brain via neural, immune, and hormonal pathways. Groundbreaking evidence in mouse and human cells suggests tangles of tau protein appear in the gut years before signs of cognitive impairment. There's exciting potential for new disease modifying therapies targeting molecules that already travel up the vagus nerve to the brain, using this new neural two-way superhighway. While a treatment using this pathway is probably some years away still, it's a giant leap toward understanding the interconnectedness of our different body systems. And with that, I'll jump into sleep. So, sleep is a complex topic. There's sleep quality, efficiency, sleep disorders, sleep physiology. It's not an easy field of study with significant overlapping of possible causes and effects, as well as ways of measuring sleep. This may be why sleep hasn't previously been included by the Lancet Commission as one of those modifiable risk factors for developing dementia. But sleep is a common complaint for older adults. 50% of older adults have some form of chronic sleep issue, most frequently insomnia, and are twice as likely to be prescribed sedatives than younger adults. Living with multiple health conditions also complicates this relationship between sleep and the brain. So, kind of like dementia, there's an unhelpful misconception that difficulty sleeping is a normal part of aging. It reinforces the misuse of drugs that are not meant to be taken for extended periods of time. Older adults are 50% of people recorded as using sedatives for months or even years at a time when they are supposed to be a short term fix. Sleep disturbances predict depression onset and recurrence. And as many might be aware, depression has been established as one of the Lancet Commission's 14 modifiable risk factors for developing dementia. So there's also strong evidence linking obstructive sleep apnea and insomnia as risk factors for Alzheimer's disease. Obstructive sleep apnea results in a lack of oxygen um, to the brain and is linked to decreasing thickness in areas of the brain associated with memory. So, that lack of oxygen and sleep disturbances have been shown to change gray matter and contribute to neurodegenerative processes. Experimental animal and human studies show that sleep deprivation or disruption of certain stages of sleep result in increased levels of indicators of Alzheimer's disease. So, one being amyloid beta in cerebrospinal fluid, and longitudinal studies, so studies over several years, have found less sleep resulted in an increase of dementia risk 25 years later. Next slide, please. So, as mentioned before, there's several different ways of measuring sleep. And the first being questionnaires, which are subjective and often unreliable. Sleep disturbance is commonly reported in memory clinics. However, the go to assessment scale is developed for middle aged people without cognitive impairment. In combination with questionnaires, actigraphy is the use of wearable technology devices like smartwatches and activity trackers. Many of us may already wear something like this. It's more objective than questionnaires. It logs a good picture of rest, total sleep time, awake times during the night, and all in someone's real home environment without having to get hooked up to unusual equipment. Okay, this one's a mouthful. Polysomnography records the pattern of brain waves that occur during the different stages of sleep and how long we stay in them. It uses electroencephalography, or EEG. The test uses small metal discs called electrodes that attach to the scalp. I was a psychology student in my undergraduate degree and got hooked up to an EEG machine a couple of times, and I can't imagine trying to sleep with all those wires on. But in combination with these three ways of measuring sleep, a study by Lamb and colleagues from 2025 found that 54.3% of people who had attended a memory clinic reported poor sleep quality, and 75% of the clinic attendees had mild to severe obstructive sleep apnea when screened with a combination of all three of these ways of measuring sleep. So, questionnaires, pulse oximetry, and polysomnography. Um, and only 12% of visitors to the sleep or to the memory clinic had an existing obstructive sleep apnea diagnosis. So there's definitely a relationship between sleep apnea and memory issues later in life. Next slide, please. So, beyond prescription and over the counter drugs and supplements, there are a few different ways to support a better night's rest. Uh, the advice we always groan at, exercise. You might have known that that one was coming. Exercise has a moderate to high effect on self reported and objective sleep in people with mild cognitive impairment, as well as Alzheimer's disease. One that also might be something people are already doing is acoustic stimulation, the fancy word for using sound to modify sleep patterns, potentially improving sleep quality and addressing sleep related issues. So, using devices like speakers or headphones to deliver specific sounds like white noise or even recorded natural sounds. And acoustic stimulation during sleep predicts long lasting increases in memory performance, as well as beneficial amyloid response in older adults. So, less of that amyloid beta accumulation. Bright light therapy is a treatment for people with circadian rhythm sleep disorder, and that works with our body's internal clock that tells us when it's time to be asleep and when it's time to be awake. One thing that helps set our internal clock is exposure to bright light, such as sunlight. Um, for anyone located in Vancouver, we know that that's not always the case once it gets really gray and rainy. So, devices like a light box, a tabletop lamp, or even a wearable visor help expose our eyes to intense but safe amounts of light for a specific and regular length of time. Definitely more research is needed on its effects and use with people with cognitive impairment. And with the guidance from health professionals, cognitive behavior therapy for insomnia modifies thoughts and behaviors that prevent restful sleep, focusing on consistent bedtime routines. And then CPAP therapy, using a continuous positive airway pressure machine to deliver pressurized air that keeps airways open. And it's the primary treatment for obstructive sleep apnea. We're really excited to collaborate with Dr. Elizabeth Keys, a BC based sleep researcher, for our November 26th Research Connects webinar. Dr. Keys will share more detailed information about the importance of sleep for cognitive and overall health. Next slide, please. So, our key takeaways: sleep is an essential part of brain health. The quality and quantity matters each night. Obstructive sleep apnea and insomnia damage brain health by reducing oxygen to the brain and interfering with deep sleep, leading to potential cognitive decline, memory problems, and an increased risk of dementia. It can also cause structural changes to the brain and increase inflammation. However, treating sleep disturbances with medications and non pharmacological treatments can improve cognitive function, mood, and alertness during the day. So again, stay tuned for our webinars. Stay tuned to our webinars page to sign up for this upcoming webinar with Dr. Elizabeth Keys at UBC's Slumber Lab. And with that, I'm happy to hand things over to Sarah.
Amazing. Thank you so much, Carrie. Okay. So at this year's AAIC, several sessions highlighted important conversations around equity, diversity, and inclusion. One area of focus was how dementia experiences can vary depending on sex and gender. Now, before we get into the science, let's pause to clarify what we mean when we talk about sex and gender. So, sex refers to biological attributes such as chromosomes, hormones, and patterns of gene expression. Gender refers to socially constructed roles, behaviors, and expressions that shape how we see ourselves and how others see us. It's important to recognize that sex and gender don't exist in isolation. They interact with one another. So, for example, certain genes may be switched on or off depending on someone's lived gender experience. In today's discussion, I'll use the terms like assigned female at birth and assigned male at birth to describe sex differences in dementia research. But I want to emphasize that none of us is defined solely by our genetic makeup or reproductive traits. That's why an intersectional lens is so important. When we think about someone's experience of dementia, we need to account for how different aspects of identity, such as race and gender, class and sexuality, interact and overlap. And these intersections can create very different experiences of privilege, disadvantage, and access to care. Around the world, people who are assigned female at birth make up about 2/3 of those living with Alzheimer's disease. Yet, until recently, very few studies have explored the role of the X chromosome in Alzheimer's. To set the stage, humans have 23 pairs of chromosomes, which carry the genes that guide how our bodies develop and work. One of these pairs is the sex chromosome. People assigned female at birth have two X chromosomes, while people assigned male at birth have an X and a Y. Historically, sex differences in dementia risk and progression were overlooked, but researchers are now working to better understand these important distinctions. As Cari mentioned, we know about APOE4, a known genetic risk factor for Alzheimer's disease. While having one or two copies of the APOE4 gene increases the susceptibility of developing Alzheimer's disease compared to people who do not have this gene, people assigned female at birth who carry this gene are at greater risk of progressing to dementia than people assigned male at birth. Research is increasingly showing that some genes affect health differently in people assigned female at birth versus people assigned male, and it appears Alzheimer's disease is one of these areas. For example, scientists have identified 29 genes on the X chromosome that are linked to cognitive changes in people assigned female at birth. Of these, 10 were associated with faster cognitive decline, while 19 were linked to slower decline, suggesting a potential protective role. And this opens up new possibilities for research and even opportunities for personalized therapies in the future. We're already seeing how important these differences can be when we look at a treatment outcome. So the Clarity AD study, which was a phase 3 clinical trial of lecanemab, a disease-modifying therapy for Alzheimer's disease, showed that on average, cognitive decline slowed by 27% over 18 months. But when researchers looked at outcomes by sex assigned at birth, the drug slowed decline by 43% in people assigned male at birth, compared to only 12% in people assigned female at birth. And these findings highlight just how critical it is to continue research that accounts for sex and gender differences, as well as the experiences of people who are intersex, non-binary, and gender diverse. And these groups have largely remained almost entirely absent from current studies. So expanding this work will not only help us better understand Alzheimer's, but also ensure that future treatments are more inclusive, equitable, and effective for everyone. At the conference, researchers shared important new insights on the relationship between ovaries, estrogen, and brain health, specifically their role within a certain age range among people assigned female at birth when menopause occurs. Researchers flagged a major misconception in our understanding of the relationship between ovaries and the brain. So, up until more recently, many assumed that once someone had completed their reproductive years, the ovaries could be removed without much consequence, and that menopausal symptoms could simply be managed with hormone treatment. But new evidence shows just the opposite. We now know that ovaries are not only reproductive organs, they are also part of the body's endocrine system, influencing many tissues and organs, including the brain. Now, menopause is the natural biological process that marks the end of a person's menstrual cycle. It typically occurs somewhere between the ages of 45 and 55, but it can also be medically and surgically induced, for example, through surgery or certain treatments like chemotherapy. During menopause, levels of estrogen drops significantly, which can bring about hot flashes, poor sleep, and low mood. But beyond these changes, researcher now shows that menopause and the loss of estrogen also affects memory, thinking, and long-term brain health. We're learning that estrogen plays a protective role by helping to reduce amyloid accumulation. So when estrogen level falls, especially if menopause happens before the age of 40, the risk of dementia increases. Both premature menopause, so before the age of 40, and early menopause before the age of 45 are recognized risk factors for dementia, whether they occur naturally or are brought on by medical intervention. And this is why there is indication that removing ovaries earlier in life can increase the buildup of amyloid plaques in the brain, which are the key hallmarks of Alzheimer's disease. Menopausal hormone treatment, so previously referred to as hormone replacement therapy or HRT, is commonly prescribed to replace estrogen that the body stops producing at menopause. It's often used to help manage symptoms like hot flashes and night sweats and mood swings, but research shows that its effects go beyond symptom relief and may influence long-term brain health, like I mentioned. What's becoming clear is the impact of hormone treatment can differ depending on both the age at which menopause occurs and the type of menopause. So, for example, for those people who experience surgically induced menopause because of having their ovaries and uteruses removed, hormone therapy may affect brain health differently compared to people who enter menopause between their mid 40s and mid 50s. So the relationship between menopausal hormone treatment and dementia risk is still not fully understood. Some studies suggest it may help reduce the risk of Alzheimer's disease or delay its onset, while others have reported the opposite, or actually no link found at all. So, until we have clear evidence, decisions about hormone therapy should be made with careful consideration of the age of menopause onset and also the individual's unique context. The main takeaway from researchers is that ovaries and hormones are about much more than reproduction. They play an important role in brain aging. By deepening our understanding of these connections, we can better support people as they navigate menopause and beyond. It's also important to recognize that research in this area has largely focused on cisgender women. We urgently need more studies that explore the experiences of transgender and gender diverse people, including those who access gender affirming hormone therapy, so that we can better understand how these treatments may shape brain health and dementia risk. So the key takeaways that we need to consider when we're thinking about genetics and gender, hormones, and lived experience is that all play a role in brain health and dementia risk. One area that's gaining more attention is the role of ovaries. While we often think of them as mainly a reproductive organ, the ovaries are also powerful players in the body's endocrine system, influence other organs and tissues, including the brain. We're learning that estrogen doesn't just help regulate reproductive health, it also helps protect the brain by reducing the buildup of beta amyloid, one of those proteins that contributes to Alzheimer's disease. And that said, when it comes to hormone treatments during menopause, researchers emphasize the need for careful use. So the timing, the type of menopause, and an individual's context all matters in determining whether hormone therapy is helpful or potentially harmful for their brain health. So the takeaways here is that ovaries and hormones are about so much more than reproduction. They play a vital role in brain aging, and understanding these connections can help us better support people as they navigate menopause and brain health. So at the Alzheimer Society of B.C, we champion the meaningful inclusion of people affected by dementia, and it's really at the heart of everything that we do. And this year's AAIC, we were so proud to be able to showcase how we're contributing to research here in British Columbia and across Canada by partnering with the Alzheimer Society of Ontario. Together, we shared the results of focus groups that explored how people affected by dementia understand and perceive disease-modifying therapies such as lecanemab and donanemab. And as many of you, as you know, there's no disease-modifying therapies that have been approved for use in Canada. Up until now, most conversations about these therapies have focused on drug development, health system readiness, and provider perspectives. But there has been a big gap in our understanding of how Canadians themselves view these treatments. So this prompted us to carry out this project. Earlier this year, we conducted virtual and in-person focus groups with people living with dementia and their care partners. And our objective here was to gain an in-depth understanding of their perspectives on this topic. So I'll summarize quickly some of the findings that came about. People mentioned concerns about equitable access. So they were worried about diagnostic delays, limited access to clinical trials in rural and remote areas, especially, and the challenges of just managing frequent treatment appointments that would be required for these type of therapies. Participants identified we identified the varying levels of comfort with risks that are associated with these drugs. So care partners were generally more willing to accept potential side effects than people living with dementia themselves, especially as the disease progressed. Participants identified the need for clear and trusted information. So they emphasized how important it was to have accessible, reliable, and up-to-date information so that they themselves could weigh the risks and benefits with their families. And these drugs also provided a sense of hope and empowerment. So they saw these disease-modifying therapies as more than just a treatment. It offered a way to regain agency and optimism about the future. So these insights remind us why it's so critical to include the voices of people with lived experience in every discussion about new therapies. And if you'd like to learn more, you can scan the QR code that's up on your screen to view our poster. Or I think someone's going to throw a link to the poster in the chat, and you can take a boo. And would also be happy to share that we will be producing a report looking to be released mid-September. So stay tuned for that. And we wanted to flag for everyone that next year's AAIC is going to be held in London, UK, and also online. So stay tuned for next year's AAIC for All. That's a free online showcase of the most significant findings from AAIC 2026. And it's open to anyone who wants to learn more about dementia research, whether you're living with dementia or you're a care partner or someone, you're just supporting somebody affected by dementia. We'll make sure to share the registration link via e-blast again, like we did this year. And here is our long reference list. We did some digging into literature to round out our presentation today. So if there's anything that really piqued your interest from what we shared today, please let us know. We'd be happy to send additional resources to you uh, based on what we shared today. I also want to flag some research recruitment opportunities. So our team supports researchers in BC and also nationally, internationally about exciting research opportunities. So I have three to share with you today. So the first is researchers at the University of Waterloo and the University of Alberta are wanting feedback from people living with dementia and care partners on a mobile app called the Guard IO. And that was developed to support community safety and help prevent people from going missing. So participating in this study would involve trying out the app and then providing feedback on what you think about it. So if that's something of interest to you, please reach out to Dr. Antonio Miguel Brizat. His email is up there. And you can also call him at 780-492-6104. A more local opportunity is from Professor Jennifer Bombish at UBC School of Nursing, and she has two exciting research opportunities to share. So the first study is a study on the impact of climate change on older adults' mental health. So given the more frequent climate-related weather events in BC, Dr. Bombish and her team are looking to understand more about how these weather events impact older adults' mental health. So participating in that study would mean sharing photos that illustrate how climate change impacts mental health. And there will be an opportunity to join a workshop towards the end of the study to share your experiences and thoughts with people who are involved in climate change policy and healthcare planning. Another opportunity from Dr. Jennifer Bombish's team is recruiting care partners of people living with dementia in the Metro Vancouver area who would like to participate in a focus group on the impact of climate-related weather emergencies like heat events, wildfires, and flooding. And the intention here is to identify strategies that help families better cope with weather events and also enhance climate resilience among our older adult communities in BC and beyond. So if you'd like to find out more about either one of those two studies, please reach out to Dr. Jennifer Bombish at gero@at nursing.ubc.ca, or you can call her at 604-822-7496. If you're wanting more information about dementia or wondering about programs and services that are offered through the Society, please give our first link Dementia Helpline a call. Our operators can support you in English, Punjabi, Hindi, Urdu, Cantonese, and Mandarin. So this is the first time we've hosted a webinar to share our findings from a research conference, and we hope that you found it informative. We would really love hearing your feedback on how we can make Research Connect's webinars even better. So we're actually going to try something new today. Instead of our regular SurveyMonkey link, we're actually going to use a Zoom poll. And so in just a moment, you're going to see a window pop up on your screen, and it's going to call Quick Evaluation. And there's 3 questions that we would love for you to answer. So maybe I'll just take a few moments here to let everyone respond because we so appreciate your feedback. So I'll just give you a moment now. Okay, so hopefully everyone's had a chance to answer those questions. So we'll hope that you'll join us for our
And
next research. Oh, sorry, go
sorry,
ahead,
Sarah.
Cari.
Speaking of questions,
Oh,
now's a great opportunity to open up the floor. We
oh, sure.
haven't seen much in the chat of questions throughout the webinar. Um, but if there are any questions from anyone in the room today, we would love to have the opportunity to see what piqued your interest.
Thanks, Cari. And even if you actually don't have a question, you can just pop in the chat, maybe the topic that you thought was, the most interesting and engaging to you.
Amazing looking at all of these
Hmm.
comments coming in. Thanks, everyone. And like I mentioned, we're really excited to bring in a UBC-based sleep researcher. We're really glad to have representation and research happening right here in BC. I know in a previous webinar, Sarah shared a research opportunity um, for some surveys about sleep. So it's a great opportunity to learn more about that.
And
Yeah,
I
oh, sorry, go ahead,
Sorry,
Heather.
Sarah. I was just gonna say I see some questions coming in here. And we can maybe start to work our way through. Thank you so much, Carrie and Sarah, for that. There's a lot of information, and I think I saw one of the comments said, "Oh, there's so many topics that could be covered," and unfortunately, we only had the time we had to cover off the some of those key findings from some of these key areas. But there was lots of research presented, and what we're, try and do as a research team is kind of highlight some of those in the monthly newsletters and the e-blasts that go out. So there's always a research section. So over the next few months, maybe we can try and slot some of the other findings and key pieces in there that folks might be interested in. So, we always appreciate hearing those areas where you're like, oh, maybe there was a particular thing that you thought, oh, I came today and I was hoping to hear about whatever that topic may be. You can send us an email. The email address is on the screen there, or you can drop something in the chat and we can take that forwards. So I think one of the questions someone had raised was around that sleep was not one of the previously acknowledged modifiable risk factors by the Lancet, and that's the organization that has pulled together the current list of modifiable risk factors. And I think one of the things we're learning is that sometimes it just takes a little bit of time for the research to catch up. And the Lancet Commission really requires a significant body of research to exist before they're going to make some definitive conclusions about modifiable risk factors. And so it's exciting to see that the research is catching up around sleep, and we're learning more about that, every year. And so that is likely something that we'll see in the next iteration. And who knows, there may be other factors that we learn about before they release the next version as well. Uh, and someone has asked about the role of ApoE4, and that individual has identified that they are homozygotic, which means that they carry one of those alleles from each parent. And so ApoE4 it's what we call a susceptibility gene. So it increases your susceptibility for developing later in life Alzheimer's disease. And there's a couple of versions of the apolipoprotein gene. There's a ApoE2, ApoE3, and ApoE4. And it's the ApoE4 that actually increases potentially our risk. But it's also important to remember that it's not a deterministic gene. So what that means is you could have ApoE4 from both, you could have an allele from both parents, you could be homozygotic for that, and you may never develop Alzheimer's disease. So it can increase the risk, but it doesn't necessarily mean that you will end up developing Alzheimer's disease. And that's one of the mysteries. What are the other things that influence and work with our genetics? What are those lifestyle factors? Things like sleep, things like exercise that might then impact that. And I would point you to a really great presentation that we had. Oh, Cari might need to jump in and remind me what month that was. Earlier this year from genetic counselor Emily Dwash, who's based at UBC. And she did a fabulous talk about the genetics around Alzheimer's disease and dementia. And so I certainly, if you've got more questions, definitely worth having a look at that webinar. And I think you might find that.
I'll pop that link in the chat in just a second.
Thanks, Cari. And I see lots of sort of comments around the menopause, ovaries, the role of estrogen, and certainly an area of women's health that Sarah's identified as has been overlooked. And we're now starting to realize that females aren't just carbon copies of males, that there are significant differences. And also for folks who are transgendered and for someone who may be transitioning and, is exposed to estrogen, what role does that play? And there's so much that we don't know. I think someone has asked about whether there was any new research looking at older males taking testosterone and whether testosterone may be implicated in dementia. And that's not an answer I know off the top of my head, but I'm wondering, Cari or Sarah, was there anything mentioned during the conference?
That particular hormone was not discussed during the sessions that we attended. But I think it would be safe to say that researchers are paying close attention to these hormones and the roles that they play in brain health and brain aging, certainly. So I'm sure there's research out there, but it just wasn't featured at AAIC this year.
And we still have a little bit of time left. If anyone's got another question around research, that there's something that you heard about today or something that you'd like to know more about, feel free to pop that in the chat. And we'll give you a couple minutes to do so. And then if we don't have additional questions, then some of you will get some found time back in your day.
There we go. Sorry, it took me a couple moments to get that link in there. But I have just put in the link to genetic counselor Emily Dwash's recent webinar recording.
And I know it sometimes takes a minute to type and to enter your questions. So as I say, we'll give you a couple more minutes and then if not, we will sign off for today. But do stay tuned, as I say, for the monthly e-blasts where there's always a research section. And we'll try and include some snippets. And then as Sarah said, flagging for next year that there is always at the end of the conference a day that is the AAIC for all, and it's free to register. And but the only way you can access that material is by registering. So it's not like the information is posted and even if you didn't register, you can access it after the fact. You do need to register to be able to have access to the recording after the fact. All right. Well, I'm seeing some thank yous on the slide there. So I'm going to take a moment and say thank you to everyone who patched in today to just learn a little bit more about some of the research advances. And certainly when I reflect on the 30 years that I've worked in the field, that some of these advances that we're experiencing at this point are very exciting and provide lots of new opportunities and some hope for the future. And I think that's particularly important. So thank you, everyone, and we hope you will join us next month. Carrie, did you want to just highlight for folks what's coming? I think you mentioned the sleep.
Yeah, absolutely. And I know apologies, Sarah, I cut you off as you were going into the lovely outro.
That's okay.
Because it was great to have this opportunity to talk over a few of these questions. Um, let's see. So we're very excited for our next Research Connects webinar on September 24th. Um, we're looking forward to welcoming project team members from the Indigenous Art and Storytelling in Virtual Reality project, led by Dr. Lillian Hung of UBC's Idea Lab. By collaborating with Indigenous partners and healthcare professionals, this project seeks to make healthcare technology more inclusive and culturally responsive. Um, in the spirit of National Day for Truth and Reconciliation on September 30th, it seemed like a really great fit to explore a much needed research project. So we're really looking forward to that one, and we will have more information on the webinars page for signing up. So stay tuned.
Thanks, Carrie. And if you want to find additional details about our upcoming webinar or any of our other webinars, please visit alzbc.org/webinars closer to the date to register for September. And of course, you can find our previous Research Connects webinar recordings on the YouTube channel. So you can click on the YouTube link that Carrie threw into the chat and then explore the other recordings that we have for you. So thank you so much from our team for joining us today. If you're interested in contributing to our knowledge on dementia, we do encourage you to get involved in a research project. Engaging in research activities can make a difference in your community now and for future generations. So if you want to find out how to get involved, please visit I want to participate in research section at the alzbc.org/research webpage. So we always love to hear from you. If you have any other questions or concerns about today's topic, we encourage you to email us at research@alzheimersbc.org. So thanks to all of you for joining us today, near and far, and we look forward to seeing you in September, and take good care. Thank you so much.